In example 48, we're going to sketch a graph of this linear inequality, and we start off by sketching a graph of the line we get when we replace that inequality sign with an equal sign. And of course, back in chapter 1, we looked at a couple of different approaches to this. I'm going to use the intercept method, so I'm going to find the x and the y-intercepts of this line. So the y-intercept we find by setting x equal to 0. And if x is equal to 0 in this equation, then we get minus 3y is equal to 18, and dividing each side by minus 3, we get y equals negative 6. And for the x-intercept, we're going to set y equal to 0. And if y is equal to 0, we get the equation 6x equals 18, which gives us x equals 3. So now we have our two intercepts, and we're ready to sketch the line. Draw some axes here, and put down a scale. So here are our intercepts, our y-intercept and our x-intercept there. Now before I sketch the line, I'm going to go back and look at this inequality. Because it's a strictly greater than, it's a strict inequality, there's no or equal to part. We know that this is going to be a dotted line. Now that we have our line, our dotted line drawn, there's only one more step to sketching this inequality. An inequality, a linear inequality, will always define a half plane. So when we graph this inequality, it's going to be composed of both this dotted line that we drew plus indicating which half plane, meaning which side of this line is going to be shaded. And the way that we figure out which side of the line is shaded is we pick a test point. And unless the line that you draw, unless the line we have actually goes through the origin, I always pick the origin to test because 0, 0 is really easy to plug in. So I'm going to test the point 0, 0. And we're going to do this by plugging it into the original inequality. So our inequality was 6x minus 3y greater than 18. And all I'm going to do is see if plugging in the values x equals 0, y equals 0, if this satisfies the inequality. Question mark there. And of course on the left side we just get 0. And of course this inequality is not true. 0 is not greater than 18. And so what this tells us is that since our test point did not satisfy the inequality, we're going to shade the side that doesn't contain the test point. So coming back up here to our graph, I know I'm going to be shading this side. And this is the graph of our inequality. This is a visual representation of all of the xy pairs that satisfy this inequality. We do not include any of the points because the line is dotted. It doesn't include any of the points on the line, but any point on the shaded side of the line will satisfy that original inequality.